All right, algebra students, here we go. We are going to tackle systems of equations and solving those systems of equations through graphing and substitution this week. So a system of equations is going to be a situation where you have more than one equation, okay? And when we're solving a system through graphing, what we're looking for is one of three things. We're looking to find out if that system has zero solutions, okay? And that happens graphically if our graph has two lines that are running parallel to one another and they never touch, okay? And we're also going to be looking for a situation where you might have an infinite number of solutions, so an infinite system. And that occurs if you have two equations that actually always touch, okay? So zero solutions is when lines are parallel, right? One line is running exactly parallel to your second line, like railroad tracks, and that would be zero solutions. An infinite system would be where I have an initial graph, and remember we're graphing these either in standard form or in y equals mx plus b, so slope-intercept form. Those are pretty much the two forms we're using for graphing. And our infinite system occurs if one graph is exactly the same as the other graph. So essentially, it's the same graph. It's just maybe looks a little bit different initially. And then we're going to get to the systems where what we're looking for is one solution, perhaps. Okay? So a system with one solution is going to be, you're just graphing those two lines. So we'll graph our first line, just like we would graphing a slope-intercept form. Then we graph our second line. And this point where those two lines intersect creates our one xy coordinate solution that makes both equations true. Okay, so that's what we're going to be working on in this unit, is finding those situations where you might have no solutions, zero solutions, infinite solutions, or one solution. And most often we're going to play in this space of having just one solution, so that xy coordinate point where things intersect. So let's go ahead and do a little graphing together, and you'll notice that both of these are in the form y equals mx plus b. So you want to identify your y-intercept and identify your slope and graph these. You guys have been doing such a good job with this. Now you just do it twice. Okay, so we'll go to 4, and then from 4 we have a slope of -1/2. So down 1 over 2. Okay, so our slope is negative, going down from left to right. Trying to do a good job graphing that for us so we can see that. And then our other graph, we'll just switch up colors here. You can see that this is a +0, so we're going to go ahead and start at the origin, and we have a slope of 3/2, so up 3 over 2. And then up 1, 2, 3 over 2, and we can make our graph crisscross just like that. So the spot we're looking for then is this spot right here. Maybe you noticed that we landed on the same dot right there. And that dot has a coordinate point of 2, 3. Which means, and what that means for this system is that if I plug a 2 in for x, and I plug a 3 in where I see the y values up here, if I plug those numbers in, that is going to make those equations true. Okay, so that is what it means to solve your system. And that's how we do it graphically. Okay, let's do one more graphically and then we'll move on to substitution. So here we go. This one you can see is in standard form, so we're going to do a little practice graphing with standard form here. And again, standard form, we've worked with it. We know we are going to look for x-intercepts and y-intercepts to do the graphing for this one. So I'm going to go ahead and write both of my equations kind of over to the side here, so we can set up solving for those x and y intercepts, graphing in standard form. So here we go. So I'm going to first make my y value equal to 0. And in doing that, basically what you're doing is you're just grabbing the x term and solving for x. If we make y equal to 0, divide by 4, both sides, and we get x is equal to -3. Okay, so I'm going to go ahead and put that -3 right on my x-axis. Then we're going to grab the y. We're going to make x equal to 0. We're going to grab this y term, 6y equals -12. We're going to divide by 6, both sides. We get y is equal to -2, and I'm going to mark my -2, just like that. Okay, and so I can see that I'm going to continue my graph along that same slope, just like that. Okay, and that helps me to graph my first line. Well, in the last unit, we were done at that point. It was like, woohoo, we're done. We found the x-intercept, we found the y-intercept, we're done. In this unit, we're going to do that same process. We're just going to do it twice. So we're going to grab our x term. We're going to make y equal to 0. So 3 times 0 is just 0. So I'm actually solving 2x equals 6. If I divide both sides by 2, I get x equals 3. I'm also going to, remember, put a 0 in for x. So I'm essentially solving 3y equals 6. Dividing both sides by 3, I'll go ahead and show you guys this division. Those things cancel. 6 divided by 3 is 2. So now I'm going to plot x equals 3. That's 3, 0. Y equals 2, so that's the point 0, 2. And it looks like, oh my gosh, are these lines ever going to cross? Look at what we have an example of here, guys. We have an example of a system with 0 solutions. So it's good for us to see an example like this. See how it's never going to cross? So this would be 0 solutions, or you could say no solutions, or you could say the lines are parallel, therefore there are no solutions. I can tell they're never going to cross because their slopes are exactly equal. This is down 2 over 3, so this has a slope of -2/3, and then the blue line also, if I go down 2 and over 1, 2, 3, it also has a slope of -2/3. So if those slopes turn out to be the same, that's an indication that you will have 0 solutions when you're graphing. Okay, so we have one example of them crossing, one example of the lines graphing and being parallel. Of course, if they lie on top of one another, that would be an infinite solution. Okay? I think we have just enough time, guys, to go ahead and tackle this second part of our learning along with this initial part of our learning and talk a little bit about substitution. So this is going to extend the length of our video a little bit this week, but I do want you to see how you can solve a system algebraically through substitution, okay? And the big thing I look for on this is I want to always try and get either x equals stuff or y equals stuff. So when you're using substitution, you want to solve for either x or y. Okay. And it looks like, and sometimes it's already solved for you. Sometimes it already says x equals something or y equals something. In that case, you're like, woohoo! That's always an exciting moment if that's given to you. For this particular problem, I'm going to go ahead and solve for this y right here. Okay? And I'm going to do that by subtracting 4x from both sides of this bottom equation. See how I have two equations here? I'm just working with the bottom one right now. So as I do that, as I subtract 4x from both sides, I have a new equation. These are going to cancel, and I'm going to have a new equation that says y equals negative 4x plus 11. Remember, I can't combine those terms because one has a term with x in it and one is an integer, so I have to just leave it as an expression. Well, what I have done with this situation is I have created y equals stuff, this stuff, right? And because y is equal to this expression, my negative 4x plus 11, what I can do is I can grab my second equation. So this is what I'm going to do. I'm going to grab this second equation, 3x minus 2 times y, and in the place of y right here, you notice I made a really big spot because I am going to do a replacement. I'm going to take all of this information that y is equal to, and I'm going to get rid of this y. So here I go. I'm going to erase this y, and in the place of that y, I'm going to put negative 4x plus 11. You see how that just went right into that spot? And that's going to be the idea with a substitution. You're replacing. Okay? All right, so let's keep after this example. I'm going to go ahead and get rid of my little arrow here just so we have some room to work. And let's go ahead and simplify. So we have 3x. We're going to multiply your negative 2 through the parentheses. So here I go. It's going to be a plus, watch those negatives, plus 8x minus 22 equals 11. The 3x plus the 8x is 11x minus 22 equals 11. I'm now going to add 22 to both sides. Okay. These will cancel. We get 11x equals 33. And if we divide by 11, lots of good algebra going on here, we get x is equal to 3. Now, as happy as we are that x is equal to 3 and we think we're done, we're not quite done. We have to still figure out what the y value is equal to. So, last step. Here we go. Y is going to be equal to negative 4x plus 11, right? But you know that x is equal to 3. So we're going to take that little 3 that we had right here, and we're going to jump it right into your formula for y, right over there. Okay, we'll just keep going. So we get negative 12 plus 11, which reduces to, or simplifies to, y is equal to a negative 1. You did it! And that's all we have time for, all right? So that is your answer. Your final answer is x is equal to 3, y is equal to negative 1, and that would be the coordinate point where your two graphs would cross. And you guys have just solved a system with substitution. Okay, we're not going to have time to do this one. You guys can try this one on your own if you'd like. I would solve for x first and then substitute that value right in there. If you do this work and want me to check it at any point in time, you can show it to me. Love to help you out. All right, guys, excellent work. I will see you in class.